condensed matter really is a very wide-ranging subject. So it's kind of hard to pigeonhole people. So a lot of people that work in condensed matter, particularly in super, won't necessarily mix in the same areas, like going to the same conferences or anything. But in the general materials, they're all interested in materials properties, or how functional materials work. So you've got things like photonic materials, you've got ferroelectric, ferromagnetic, multiferroic stuff, quantum materials, thermoelectrics, nanomaterials. There's also a lot of work done in theory. So say my area is magnetism, but I don't do really much in photonics, but I could apply some of the things that I do to things like photonics, for example, electron microscopy. So it is a wide-ranging theme, and it's actually a good theme to be in, because you talk to other people, quite often you'll get new ideas from people. There's also a very strong overlap with condensed matter and some of the other themes like energy, because energy tends to be used materials to harness the energy, and it's the properties of that material that's of interest. Photonics obviously is a big overlap there. The optical stuff is covered there, but photonic materials then really comes into the realm of condensed matter as well. So if you're doing a PhD in materials science, then probably your host institute will be the best place to look at what's most suitable for you. In terms of super, there will be some general courses in materials science that might be more relevant to your PhD. So this is definitely a question that you want to discuss with your supervisor. So the common courses that are run most years are like statistical physics, quantum field theory, condensed matter physics, quantum devices, soft matter. And some of these are quite specialized. But again, some of the courses that might not look relevant to you, there might be some bits that you can pick up there that will be of interest. But you should be able to get advice from your supervisor and actually other students in the research group that you're in. Again, condensed matter is very wide-ranging, so it's kind of hard to pin this one down and say my condensed matter is a small field, and then the whole of condensed matter, even within super, is a huge thing. So I think the broad areas that you'd be looking at, and again, this is something you'll probably get from your local research group and supervisor, is something to look at. But where things are hot, let's say, are things like quantum materials. And that covers quite a wide range of materials topics, and there are some of the nodes in super that are looking at that. Photonic materials is the other one. Functional materials, again, that sounds a bit broad, but anything like semiconductors, magnetism, nanomaterials, smart nanomaterials, two-dimensional materials. These are all things where there's things happening. But to be honest, in most subjects, things like thermocalorics, for example, or thermoelectric materials, there really is a huge range. It's hard to then say what's exactly cutting at that, because I don't have the knowledge of all of those fields. But again, I think if you're in a super research group, you're almost certainly going to be on something that will be close to the cutting edge. So I think then it's up to you to then, get yourself involved in the field and find out how you can make a difference, because that's one thing to remember about super. It's not you just doing a project. You should be driving the project forward, so bringing things to project as much as possible. So the question would slightly put the question back is you try and drive this forward yourself to make what you're doing is cutting edge. A PhD opens up a door to go into anything, to be honest. Really depends on what you want to do. Obviously, the natural place to go is in science, and actually science and engineering, I would say broadly, is where people will end up. Now, whether they end up in physics or engineering, or sometimes even in bioscience, biophysics, these are all possibilities for people. But the most common things what people be looking at is things like photonics, photonic materials, functional materials. Again, that could be semiconductors, superconductors, magnetism. I think about all the industries over the world, they're crying out for graduates who have got a good material science background. as well as industry, people go into academia as well. Again, the statistics there are that, you know, there's not that many people that make it into academia from people that do the PhDs, but there's still possibility of doing that. So again, that's something some people are interested in. So going into a postdoc, that would probably be the stepping stone to then see, yeah, is there a possibility of you doing it? You'd probably need to be applying for a fellowship when you're there, and then that strengthens your case for getting a lecturing position, or you might decide do one postdoc, then go into industry. It's a balance between, you know, freedom in the academic world, you have to do teaching, and then a job in the, you know, the commercial sector, which might be better paid, but, you know, you're focused on one particular thing. So there's lots of things that people can do, and actually, even from people from my research group, they're all over the world doing different things. So there's never really a sort of thing, this is what you're going to end up doing. Actually, it's really down to the individual. So there's I think there's lots of opportunities. A PhD is still a great piece of currency to have. Saying I've got a PhD in materials science, and you can apply for many different jobs, and actually move between different disciplines as well. So I think it's a great thing to have. Thing that I would say is each PhD is a personal journey. So your PhD now, the thing you'll notice it's different is you're not in a class anymore. Yeah, okay, you might be in some classes, but actually your degree is for you. So, you know, you're expected to take ownership of that PhD as early as practically possible. You'll obviously spend the first year getting familiar and getting yourself up to speed with things. But really then, you know, you really should be taking things forward. One thing I would say is talk to people, talk to lots of people, because sometimes you might talk to people and get absolutely nothing out of the conversation. That's quite normal. But in the most unexpected times, what you will get is you'll get a nugget of information from someone, or they'll tell you about something they're doing. You're like, well, I could do that for my material or whatever your project is. And actually, that's something that's quite what we call serendipity, right? It's just you speak to someone, you end up with something useful out of that.